Audio, okay, full clear. Voice full clear. Okay, I'll start. See, now one question I won't explain because this is already known for you. Why should I waste time? See, we have solved the question when point load is here, then when couple is here earlier, then UDL is here. Now when UVL is here, only change. This is already over earlier. See, if you apply moment area method, see this diagram, parabolic, this is parabola, cubic of third degree. Area equal to, see when UDL is there, see, it is second degree, this is third degree. Area 1/3 base into height, area 1/4 base into height. CG is at 1/4 here, CG is at 1/5 here. So on that basis, you get the answer. I won't waste time. And trick or shortcut, what do you do? See, this is bent. Find YC and theta C by formula. You know it. For this triangle load, theta is WL cube by 24 EI. Deflection is WL power 4 by 30 EI. Find out those two. Then you find extra deflection. Then find YB. This is already over. And there is no point in wasting time. If you go through all this question, first of all, even if I am not told, you should have done it. But still, to make perfect everything, solve this question. Clear now? I'll remove it. I won't maintain it because I want to start new. I don't want unnecessary to waste time. Clear question? No point in wasting time. Okay, start. Now, go to next question. But before going to next question, see, there is an important principle for cantilever. It is sometimes very useful for computer examinations. I will tell you first that one. See, first time being, for some time do one thing. Any loading will do. See, you make a note. See, there is an important concept. Important concept, of course, shortcut also concept. See, do not by heart left side fixed, right side fixed. One side fixed, one side free. Imagine, you should write everything. Imagine a cantilever. See, this way. Some random load is there, any type of loading. This I tell A, very important. Don't by heart A. A is fixed end. B is here, free end. You tell fixed end, free end. Any length will do. See, imagine length is L. Length is L. Now, if standard formula applicable, you can happily do it. But sometime there will be a partial UDL on this side. Or some loading can be given where formula will not work out. In such cases, see, I'll do one thing now, L. Okay. Just any point, consider, see, consider any point in between, say some name required. Last time I told you what? A point Q, after that there is no load. This is not Q, not that way. Any point, I will tell A, B, any random point, say R. Any random point, R, where, see, this is the point R. This is a cantilever, some loading is there. See, this is any random point R. Don't by heart left side, right side. Any point R. Do one thing. From fixed end, some distance. From free end, some distance. Total is L. So any name you can give. I will do one thing now. I will call this as L dash and L double dash. So remember, in case the cantilever is like this, any random point R, see this is AB, you should take L dash from here, L double dash here. Why? from fixed end L dash, remaining L double dash. Later, we will remove all the symbol. Okay, start. Now, suppose you want to find slope and deflection y at free end. Imagine formula is not applicable. And also you may require theta and y at any point, say R. That any point, that is that random point R. So now I use a color for that one now to understand. See, for that one I use a color. Red is better. Okay. In time not getting. Okay. Red is somewhere here. Yes. See, the point R I will take here. From left side I'll call L dash. Right is black. Okay. Now, what you do is from fixed end. First, what you do is consider a cantilever. From, very important, fixed end up to that point R. Okay, see here. That is, see, this is my original. This is A, don't by heart AB. This is the point R. This I am taking L dash. Remaining is L double dash. That is that L dash length. Consider the cantilever up to here. That's all. Now, this is the point R. Find what? Slope at R, deflection at R, and also slope and deflection at B if required. Suppose if the question is only to find R, that's all. But in the question, if slope and deflection require the free end, now only find it. Also at not B, at free end. Here, find slope at R, deflection at R, and also slope and deflection at A. How? For that, what do you have to do? For that, you have to consider, remember, whatever load is here, see, whatever this load you have to consider, plus this side load remove. For this, which, see, from R up to free end, whatever load is there, replaced by force and couple at R. That is, see, if I take only this cantilever, this load is there. See, from that side, whatever load is there, transfer the load here and it will create a couple, transfer the couple. Clear concept? Clear or not? What from the free and remaining portion, transfer it. Okay, now draw elastic curve. See, space is there. If space is there, I will write it here only. Yes, I can manage. Now draw elastic. One thing now, space problem, or I'll do one thing here. See, consider the loading, consider the replaced by load and couple. Okay, now, okay, right. Write elastic curve. Remember, this will bend like this. That side portion, you do not consider this load. That's all. We want to bending only for this cantilever. So, tell what happens. Actually, curvature is there that side also. That is later. See, this way, then it will become this way. Correct? Why? Because remaining portion of cantilever you consider unloaded. Oh, remember, right here, remaining portion of cantilever on the free end side, consider unloaded because its effect is transferred here. It will be a straight line. Now you know how to find this one, deflection at R, and also you know how to find theta R. Then this is the extra deflection y naught and theta y naught. This is theta at B equal to theta R. This is already over yesterday. Yes or no? Fast. This is already over yesterday. Tell yes or no. This concept to the right, to the free hand side, whatever load is there, its effect is transferred here. Now, the remaining free hand, don't consider loads. Okay. Now, you get the answer. So now you can find what? Deflection at R, theta R, and deflection at the free end will be equal to yr plus y naught, theta remains same. Okay. Now what you do is, now consider another cantilever. Another cantilever. Cantilever from that point R up to free end. Up to free end. That is, see, that is this way, see. This is the loading. Up to R already over. Now do one thing and fix that R. Because whatever slope comes at R is already accounted. Now no more slope at R. That is, see, that is like this. This cantilever. Apply the load and consider loading. That is, whatever is there for remaining portion, you write. See, this loading, elastic curve will become this way. Find this theta and y. Theta, this is B. Theta B and yb. This is not that yb. This is not that yb, some other yb. You don't have to write theta b yb. You write formula, that's all. Then tell the answer. Slope and deflection at B will be, what, tell me? Slope at B equal to whatever slope at B you got from this slope. It is theta B, or I'll do one thing now. I will call theta B dash, theta B1, yb1. This is, I will call theta B2, yb2. The real theta B is earlier theta B1 plus new theta B, theta B2. The final deflection yb, final, equal to whatever deflection you got here, yb1 plus the new deflection yb2. That's how you find. I will give an example now. You go through this again and again. Tell me, fully clear? Full clear or not? I will give an example and correctly explain it now. I will give an example. I will take a chance. Lastly, answer not telling, I will be in trouble. Okay. See, now, just to understand the concept. See, for example here, I will tell you, just to understand the concept. See, imagine there is a question. There is a cantilever beam, any length will do. Cantilever beam, say, I want cut length, this length. Okay, 1 minute, full length. Cantilever beam of length, 6 meter. Okay, 6 meter. It is loaded by UDL of intensity, any intensity, say 40 kilonewton per meter over the entire span. This I will call A, this I will call B. This is a question. Now, question is, find slope and deflection at free end. This you can find directly by formula. Tell yes or no. You don't require all these things. This you can find directly. Tell yes or no. Yes, but remember, I will tell you what is the use of this procedure, because in case it is non-prismatic, tell me, can you applying a formula, can you find slope and deflection? Tell me. If the EI is different for two portion, non-prismatic, then can you find slope and deflection by formula? Tell first. If it is non-prismatic, EI different. Can you find slope and deflection at the free end? No. That's why I am telling this principle. So find slope and free end, and also adallade uske alawa theta and y at a new point, any point, at a point C. Where is C? C is at ಇದು 6 ಮೀಟರ್ ಇದೆ, ಒಂದು 2.4 ಮೀಟರ್ ಚಿಲ್ಲರೆ ಇರಲಿ ಫ್ರಮ್ ಬಿ. ದಟ್ ಈಸ್ ನೋಡಿ ಇಲ್ಲಿದೆ, ದಿಸ್ ಈಸ್ ದ ಫ್ರೀ ಅಂಡ್ ಬಿ, ದಿಸ್ ಈಸ್ ಎ, ದಿಸ್ ಈಸ್ ದ ಪಾಯಿಂಟ್ ಸಿ. ನೋಡಿ ಸಿ. You or for this question we want theta be how much, deflection at B how much, theta C how much, and deflection at C how much we want. Okay, now whatever you do, now only tell me, finally whatever you do, finally tell me theta B. Don't see this point, tell the formula. What is formula? If you see the full beam, don't worry about that one. Cantilever with UDL, span is 6 meter. This is free end B, EI is constant. See, here you can apply formula, but non-prismatic you can't do it. Theta B equal to WL cube by, how much answer tell me? You do whatever you want, but finally theta B, WL cube by, answer. Tell me now only. I am taking a risk now. Why risk? By commitment this way, if answer is not coming, remember, I will be in trouble. Answer, I am willing to face the risk. WL cube by 6 EI. This is just a note. Answer, 40 into 6 cube divided by 6. Anybody can tell the answer? Something by EI. Answer, 40 into 6 cube by 6, you know the answer. 1440. And deflection at B equal to WL power 4 by 8 EI, because when the beam bends this way, deflection at B equal to 40 into 6 power 4 by 8 EI. Tell the answer. Deflection, don't give wrong answer. 40 into 6 power 4 by 8 EI is the deflection. Fast. Now see, I am risking my reputation by telling the answer in the beginning. If I don't tell the answer, what I can do? I can escape later. 6480 by EI. Therefore, irrespective of whatever trick you apply, how you solve the problem, cut to wherever you want, divide the beam into how many parts you want, lastly your slope at B and deflection at B, that is at free end, that they are nothing but the maximum values. They are the maximum values should come 1440 by EI and 6480 by EI. Okay. What do you feel? Will it come? What is your feeling now? I am going for something else now. What do you feel? Will it come or chance of mistake? What do you feel now? I want little boosting, confidence to build up. What do you feel? Will it come or not? I'm under tension now. What do you think? Will it come? No. I am now breaking the beam. Okay, certainly. Thank you. One ನಿಮಿಷ. Later. Don't put me in trouble. Okay, now leave everything. Start fresh. Now do one thing. They want theta C y C. So, see, there is no formula for theta C y C. So, right here, suppose in an examination, if they give this question, if they ask you free end value, directly you get the answer. But who knows? In competitive examination, they may ask you slope and deflection at any random point. Usually center they will ask. Center you do homework. If you want center you do homework. How to check the answer? Continue further. Finally you should come back here. Can you try? Instead of this point C somewhere here, you take it center. Then answer will be different. But when you shift it to free end, finally same answer has to come. Can you take homework? The point C by taking center. Can you take homework? That is, it of split. Can you take it as homework later? Okay. Now, start. First, see. Now, put the sketch once again. There is a new point here where I want red color. Point called C. Remember, this distance is red color I want. They told from free end 2.4 meter. Means from fixed end 3.6 meter. Okay, start. Now, first consider what? Consider only AC as cantilever. Nodi, red color, here whatever red color is there, consider only the red color as cantilever. A to C. Okay. And find what? Theta C and YC. Stop there if the question is only to find theta C, YC. Suppose objective question is, see, then this is the best solution. If the objective question is find slope and deflection here, then find and stop. Okay. And since you require slope and deflection at the free end, also find theta B and YB for this, not real answer, for this cantilever. Okay, start. Fixed end here, red color beam, red color, this is your point C, C. Okay. UDL is here, how much? 40 kN per meter. Span of this beam, red color span is 3.6 meter. And remember, since I am removing that side, when you take this bending, the load on that side will cause bending here. You should consider a point load here and a couple here. This I should not explain how to get. Anybody can tell me this load? That load equal to 40 into 2.4. Why? The remaining load. Answer. 40 into 2.4. 96 24 96 How much? 96. And that couple is 40 into 2.4 is the load into 2.4 by 2. Tell the answer. That couple. Don't give wrong value. This is the point load. Couple. 40 into 2.4 into 2.4 by 2. 115.2 is the couple. Kilonewton meter. Make a note how it came. Okay. Make a note how it came. Okay. Now do one thing. Now draw in. See, this length is what? 3.6 meter. 3.6 meter. Now draw elastic curve. See, red color portion is here. Elastic curve will come this way. Okay, now, if your theta and y at B, if it is not required, stop here. Write a note. Suppose the question is a question where UDL given, the question is not free end slope and deflection. Question is only slope and deflection at here. Of course, you can check by Macaulay's method. Take a section here, put x equal to 2.4 and check the answer. Okay, now, but since we want slope and this is the point C, C. This is the C point. Since you see not there, C will come down here. Okay, kalle C. But since we want, see, this is the original C. Since we want slope and deflection at B, draw a tangent, it will come here, light out of scale. Okay, now, find what is, okay, see here. Find what is this deflection and what is this slope. See, no space, I will write here. You should write this deflection and this slope. I will show calculation here. Okay, slope due to UDL 40 into 3.6 cube divided by 6 EI plus due to that point load I will go in the order, UDL over, point load, 96 into 3.6 square divided by 2 EI, plus due to that couple, 115.2 into 3.6 by EI. Tell me the answer equal to, answer. See, for UDL, WL cube by 6 EI, for point load, WL square by 2 EI, for couple, ML by EI. Answer. First answer. Do not give wrong answer. Give perfect answer. That will give slope there. This will not take much time. UDL, WL cube by what? If the UDL is not there, only that point load and couple. First. I want the slope. It beka. Do not give wrong answer. What this much time? 40 into 3.6 cube by 6 EI, 1347.84. Confirm it correctly. 1347.84 by EI. Okay, right here. This is 1347.84 by EI. Okay. Deflection. Start. UDL. 40 into 3.6 power 4 by 8 EI. Actually, EI you can cancel. Plus point load. 96 into 3.6 cube by 3 EI. Plus couple. 115.2 into 3.6 square by 2 EI. Answer. For UDL, WL power 4 by 8 EI. For point load, WL cube by 3 EI. And for couple, WL square by 2 EI. Answer. The deflection. Do not give wrong value. Do not give any wrong value. If answer is not telling, why should tell calculation mistake? Be a little careful. Why so many are there? At least type the answer. Not only one or two. Others also should contribute. Wrong means you are in problem later. If you give wrong value, answer will not tally. 3079.296. 3079.296. 0.296 by EI. Okay. This is also over. Now I want, see, if that is theta B, see, this theta is equal to this theta. Yes or no? Remember it? These two are equal theta. Don't put theta B all. Symbol not required. These two, and this deflection already you got. 3079 point something. Or I write there only. How much it is? 3079.296 is by EI. This theta equal to this straight line. Now, you find what is the extra deflection here. That I used to call Y naught. That will be equal to, I already told repeatedly last time. I won't explain now. It is 1347.84 is the theta multiplied by subsequent distance of, this is 2.4 meter into 2.4. That will give you this extra deflection. How much? Tell me something by EI. That extra deflection there, beam remaining portion, remember no curvature for remaining portion because why? That is because you are considering this bending of this cantilever, that load is transferred here. Now that load is not there. 3324.816 by EI. Okay, by all meter. Okay, now you can confirm and tell. Therefore, your slope at C, theta C, if they ask in examination, is what? Theta C, 1347.84, 1347.84 by EI, radian clockwise, and deflection at C, if they want in examination, is 3079.296 by EI meter down. This is the answer at the point C if they want. But they want also at B. See, don't calculate now. Now, leave it. Now consider new cantilever. Cantilever starting from where you stopped earlier. Starting from, tell me which point. Where you stopped earlier. Tell me. Where you stopped earlier. The bending. Curvature portion. Where you stopped earlier. The curvature part. Actually full beam curvature is there. Where you stop the curvature. Which point? Where you stop from that point. Starting from that point. Which point? Where you stop the curvature. No, tell me. Where the previous cantilever stopped. C. From that point C up to free end. Up to free end. And remember, fixed at that point. Because why? That point slope already accounted. Fixed at that point C. That is C. Something like this. Or you can write, if you want, you can write here. See? Or, 1 minute here, I'll write here. This is the cantilever of span 2.4 meter. UDL is how much? UDL 40 kilonewton per meter. This beam will bend like this. Therefore, this deflection equal to, and this slope equal to, right here, this slope equal to new cantilever UDL WL cube by 6EI. How much? 40 into 2.4 cube by 6EI. And this deflection equal to 40 into 2.4 power 4 by 8EI. Tell the slope and deflection. That is the point B. This is the extra bending. See, because of the bending of this portion, we got displacement there. But further bending is here. Answer. Slope at C, B. 92.16. 92.16. 92.16 by EI is the slope there. Tell the deflection. 40 into 2.4 cube by 6 EI. Deflection. This is 92.16. Okay. By EI. That one. 40 into 2.4 cube by 8 EI. 165.888 by EI meter down. Over. All over. Therefore, or I will tell here, to understand this result, to understand, I will transfer here. So if I take a second beam now, just one, hey, come here. The further bending of the cantilever will bend it like this. That will give extra deflection here of how much? 165.888 by EI meter. Actually not required, just to understand. And it will give extra slope here of 92.16 by EI radian. Okay. Therefore, all over, I can remove everything now. Therefore, finally, theta at B, that is at free end equal to, see, already there is a slope of, these are equal slope, 1347.84. 1347.84 is a red color value by EI plus extra value of 92.16 by EI. Tell the answer something divided by EI. And see that my reputation is not lost. So that I am not losing face. It answer. So that I don't lose face. (1440) by EI. 1440 by EI. Oh, aha. Kannada or Hindi, English. Aha. perfectly tally. And lastly, finally, deflection y at free end B. Final. This is nothing but your theta max. This is nothing but your y max equal to, see here, when you consider this bending, this came down by 3079.296 by EI. Then, because of this rotation, free end came further down by 3324.816. These are the sum of the two red values. This is this effect plus extra deflection now of 165.888 all divided by EI. Please save me by giving the answer. Please save me. See that my reputation is not lost. I don't have to repent and tell, sorry, this principle is wrong. Tomorrow I will study and come back. So, very sorry, I started something which I cannot complete. Sometimes it happens. People start something which they cannot complete. 6480. ಏನು question mark ಏನು? Why question mark? Why 6480 question mark EI? Ayyo. What is this one? Question mark. Oh, when you typed slash, you replaced by question mark. I got a shock. Why question mark? Typing mistake. 6480 by EI. This much EI meter down. Oh, perfectly tally. Clear concept? This is very useful if you are finding slope and deflection at an intermediate point, or if there is complication for applying formula for free end. Clear? If there is complication for applying formula at free end, or if for any loading, if an intermediate point slope and deflection required, you can apply this trick. Clear or not? 6479.98. No, sorry, nothing doing. Yavudu calculator adu? How it is possible? No, even 2 paisa I won't sacrifice. Impossible. 6479.98. Beku anta 6479.98 means I will stop the class. 6479.98. Adengadu? Where is my calculator? ಮತ್ತೆ ನನ್ನ ಕ್ಲಾಸಲ್ಲಿ ಚೌಕಾಸಿಯ ನಡೆಯೋಲ್ಲ. ಆಯ್ತು, ಟೆಲ್ ಮಿ ಕಾನ್ಸೆಪ್ಟ್ ಫುಲ್ಲಿ ಕ್ಲಿಯರ್. ನಾವು ಐ ವಿಲ್ ಗೋ ಟು ಅಪ್ಲಿಕೇಶನ್. ಕಾನ್ಸೆಪ್ಟ್ ಫುಲ್ಲಿ ಕ್ಲಿಯರ್. Concept fully clear. Okay, now what I will do is, see, I will go to a new question. See, I will tell you what is the problem for the question first. I first thought of writing that question, then change my mind. No, let me write it in front of you only. Otherwise people will think what? Oh, this person writes earlier and then tells he knows concept. Prepared earlier. No, I do not want that one. Okay, see. Now, we are done. See, when a cantilever beam is loaded by load UDL, if full span is no problem. If partial span is from here, no problem. But if partial from that side given, then I will tell what to do. Start one by one. One typical question, important from exam point of view. See, once upon a time, long back, there was a cantilever beam of length, any length will do. Okay, of length, ಎಷ್ಟಪ್ಪ ಲೆಂತ್? ಒಂದು 4 3. ಓಕೆ ಓಕೆ ಓ 7 ಮೀಟ್ರಾ? ಬೇಡ. ಓಕೆ 7 ಮೀಟರ್. ಓಕೆ, ಚಿಲ್ಲರೆ ಬೇಡ, 7 ಬೇಡ. ಆಫ್ ಲೆಂತ್, ಓಕೆ 5 ಮೀಟರ್. It is loaded by UDL of anything, some 36 kilonewton per meter. Why I take 36? Because I want to avoid changes. For a length of 3 meter from free end. This is A, this is B, this is C. Okay, C. Now, question is find theta C and YC, this point, and also theta B and YB. Actually, competitive examination, they may ask you only theta B, YB. I will tell you what to do for each of them. Start. 1 minute. First, we will do one thing. First, we will go for moment area method. But so many people don't like it. Okay, down. I'll start here. Go for moment area method. Then I'll go to shortcut, moment area. See, moment area is so powerful that it is very easy. Start. Consider the beam. UDL is here. It is 36 kilonewton per meter. This is the point A, this is B, this is C. This length is 2 meter, this length is 3 meter, out of scale. Draw bending moment diagram. Bending moment at B, 0. Then, see, this is the point B. Bending moment at A and also unit at C. I will not explain. See, BM at B, look free hand side, 0. BM at C is this side. 36 into 3 into 3 by 2. Sign not required. That much hogging. Answer. 36 into 3 into 3 by 2. That much hogging BM. Answer. Wrong value ಕೊಡಬೇಡಿ, correct value ಕೊಡಬೇಕು. 162 ಜಾಗ ಬೇಕು ಬಿಡಿ, ಇಲ್ಲಿ ದೊಡ್ಡದ ಬರೀತೀನಿ ನೋಡಿ. How much here? 162. So here it is 162. Joined by a parabola. Why? UDL, parabola of second degree. Remember. Over. Tell me, for this curve, area equal to 1/3 of base into height, and CG is at what? 1/4 of base from here. See, these all you know it. Tell yes or no. Area, see, this base length is 3 meter. Base length is 3 meter. Area equal to 1/3 base into height, and CG is at 1/4 from here. Repeatedly told. Yes or no? Fast. This is correct. Why? Here you can apply formula. Clear or not? Clear? Bega. Area 1/3 base into height. CG at 1/4 from here. Here 1/4. There 3/4. Okay. Now you need bending moment at A. What will happen is load is same. 36 into 3 is the load only, but into 2 meter outside distance is there. Outside 2 plus another 3 by 2, half of 3. Tell the answer. It will be high value here. That BM. How much? I want full BM here. How much? BM at A. 36 into 3 is the load, into 2 plus 3 by 2. 378. Full is 378, joined by a straight line. Okay, straight line. Now, so this is trapezium. Usually trapezium, you need not panic, but later, I don't know why. Recently, I started some teaching for someone. Even he told, sir, trapezium, sir, you have got fluency, but students find difficulties, sir, confusion. Okay, better. Then do one thing, divide into parts. Then, if this is how much? This is 162 means this also is 162. Okay. Tell me the remaining value here. Tell me remaining value. So, remaining value here, how much? Remaining value there. So that you get triangle and rectangle. Remaining value there, first. 216 is the remaining value. Oh, 216. Now, this is parabola, this is rectangle, this is triangle. Okay, start. I will start here. First, I want one by one. See, statement I will not tell. Wherever you want slope, it is the area of the BM by EI diagram from there up to fixed end. Wherever you want deflection, it is the moment of the area from there up to fixed end about that point. So I will start. I want theta C. Okay, I want theta C. Area of the BM by EI diagram from C up to A. That is this area. Start. This base is 2 meter. It is 2 into 162 plus triangle half into 2 into 216 by EI. Answer fast. Theta C. Why baritina? Theta C, YC, and theta B, YB. Fast answer. 216. Adenge 540 by EI. Radian clockwise I won't write. 540. Sakbadi. 540. Then I want deflection at C. You should write moment of the area of BM by EI diagram from C up to fixed end. This range, what area is there? Moment about C. Look this side. How much? 2 into 162 is the area into moment about this point. Half of 2. Half of 2 plus this area. Half into base 2. This 2 is not this 2 into height. 216 into its CG will be somewhere here about this point. 2/3 of 2. Divide by EI. Tell the answer. That will give deflection at C. I will solve by different ways now. I will solve it by different ways. S2. I will solve it by different ways. 612 by EI. Should I have 612 by EI. Over. Hey, amele same barbeku. Okay. Now slope and deflection over. I will remove this one now. Why waste space? I will do fresh now. Now I want slope at B. Area of BM by EI diagram from B up to A. Full area. Full area. How much? Start here. 1/3 of base 3 into height is 162 plus rectangle 2 into 162 plus this area half into 2 into 216 divided by EI. Tell the answer. That will give you theta B. Little fast give the answer. That will give you theta B. 702 by EI. Okay, adu aaytu. 702 by EI. But meter I am not writing. That already over long back. I don't want to waste time telling same thing again and again. Now, deflection at B required. Moment of the area of the BM by EI diagram between B and fixed end means full area, but moment about B, moment about this point. Therefore, start. 1/3 of 3 into 162 is 162 is the area into its CG from here 1/4, from here 3/4. 3/4 of 3 plus this area 2 into 162 is the next area into its CG from here 3 meter outside plus another half of 2 plus one more area half into 2 into 216 is the area into its CG is here. Moment about this point 3 plus another 2/3 of 3. 2/3 of this, 2/3 of 2. Answer divided by EI will give deflection at B. Answer. These all you understand thoroughly. Every problem understand. You will learn lot of concepts for how to find slope and deflection, principle, behavior, and any tricky question comes, you can at least think. Or, okay, someone wrote and rubbed it immediately. Wrong answer. First part, don't give wrong values. Because I am removing everything. If wrong value given means, I can't come back and check. 2596.5. 2596.5. By EI, that much what you decide. I got a better work to do than explaining every class. Slope is that much by EI. Radian, deflection is that much by EI. Meter all. I won't waste time. Over. 2596.5. Question is fully solved. Okay, now, exam if they want slope and deflection and B, do this way. If they want here, look this side and tell it. Okay, now, moment area is clear. Now do one thing. See, shortcut. Now see now. This beam, problem is what? There is no formula for this one. Formula is there. See, if the UDL is this side, then you got formula. See, yes or no? It will be parabolic here, curvature here, and straight line here. If fixed end side UDL is there, you have done it earlier. You can take a cantilever here and apply the formula. Tell yes or no? Yes or no? If the UDL starts from fixed end, you can apply formula. Tell yes or no? You should make all the note. Yes, but there is no formula for UDL on free hand side. So, what you can do is what? You can go to that special thing told just now. What is the special thing? Go to shortcut. Shortcut. Or what is explained in the beginning of the class. I thoroughly explained that one. Right here. What? Considering AC and CB. First consider only AC. Only AC. See, A to C. I am not putting red color. I don't think I write here. First consider only AC. Consider only AC as a cantilever. Now statement I am not giving. Why? How much? AC. The length of this cantilever is 2 meters. Tell me, is there any load on AC? Tell me, is there any load on AC? Is there any load on AC? First, is there any load on AC? No, leave it. But even if there is no load, you should what? Replace the load that side. So the load this side will give a downward load and a couple. You should do it. Tell me downward load. 36 into 3 is the downward load. You should do it. I won't write. Why? Just now I explained. 36 into 3 is the downward load. How much? 108 kilonewton. 108 kilonewton. And 36 into 3 by 2 ABC will give what? Couple. Answer. Couple. 106 R. Ayo. 106. Okay. R muda. 108. 108. Correction. 108 kilonewton. You should write. How you got? Couple. 36 into 3 by 2. That is the replacement of the load on this portion. See, there is remaining 3 meter length here. That you replace here. 162 R. 162. Okay. Ega. Now, this is the B. This is B alla. Idu C idu. Idu ima B. Now draw elastic curve. Red giddal. No red giddal. This portion will bend like this. Then straight line. Okay. Tell me what is this deflection. Directly you should calculate. This deflection. How? due to point load 108 into 2 cube by 3 plus due to couple 162 into 2 square by 2. EI I am not writing. Answer. Due to point load, deflection is what? Deflection is, I will enter the answer here. See how I got? See, I will put a dot here. How I got that value, I will explain there. Due to point load, WL cube by 3 EI. Due to couple, ML square by 2 EI. That answer. 612. 612 by EI. And this slope, I will put double dot here. I will show the calculation here. Double dot. How much? Due to point load, 108 into 2 square by 2 plus couple 162 into 2. Why formula? WL square by 2 EI for point load, ML by EI for couple. Answer. Answer. It will become 540 by EI. If that is 540 by EI, this also is 540 by EI only. And tell me what is the extra deflection at C. This is C, this is B. Tell me this extra deflection, why not here? 540 into 3. I am not showing calculation. There is a limit for explaining. 540 is the slope here into 3. Extra deflection. 540 into 3. Extra deflection there. That is a straight line portion. No curvature. 1620. Okay. By EI. Now, below, consider another cantilever from here to here. Now, where from C up to B. Now, C is fixed. Now you got loading, UDL. How much UDL? 36 kilonewton per meter. Therefore, this beam will bend like this. Tell me this deflection and this slope. Tell the answer. This deflection is 36 into span is to, what is span? Span is 3 meter. 36 into 3 power 4 by 8 EI. Answer. The deflection there. 36 into 8 power 4 by 3 power 4 by 8 EI. That is UDL deflection. So ಬೇಗ ತುಂಬ ಲೇಟ್ ಮಾಡಬಾರ್ದು. 364.5. That is 364.5 by EI. Slope, how much? 36 into 3 cube by 6 EI. How I got this answer? 36 into 3 cube by 6 EI. I explained one question so systematically. First of all, I should not explain anything. It to 162 by EI. Therefore, the final answer, whichever they want, see, therefore, finally, your theta C, if you want, is 540 by EI radian. If you want deflection at C, answer is 612 by EI meter down. If you want slope at C and if you want slope at free end B, it is this slope of 540 plus extra slope of 162 by EI. Tell the answer. This slope is 540, extra slope is 162. Tell the final slope there. Final slope there. 702 by EI and deflection at B equal to, see, this point B will come here. So it will come down, if it is 612, this also 612. 612 by EI plus 1620 by EI was the answer because of the left side answer. Plus extra deflection of 364.5 by EI. Tell this answer. Something divided by EI. 2596.5 by EI. Now, check the answer we got by moment area method Just comment, tallying or not tallying. In my class, when I ask comment tallying or not tallying, without seeing whether answer came or not, in engineering mechanics or strength of materials or structural analysis or matrix method or finite element method, you need not bother. I am there. You can type tallying. At least tell me tallying. It has never happened so far, will not happen now, will not happen in future also. Okay, over. Now, one law, thoroughly clear, all these concepts, thoroughly clear. I'll tell you why I am telling all this. There's a reason. Clear. Okay, now, just to understand, by chance, right here, by chance, for this question, it is only theta max and y max required. That is what? Theta max is theta b, y max is yb. Suppose the point C is not required. Moment area is there. You got a short solution. Then a trick will do. A trick. What you do is, see, you consider a cantilever of length full 5, highlight here. You see, space problem is there. You write it, no, I am removing. Suppose, right, I am removing it. Suppose in the question, usually examination, they always ask what is the maximum slope, what is the maximum deflection. Other point, they don't ask. In that case, you can do very shortcut, see, very fast. First, consider a cantilever A up to C. Single line will do. Okay, double line. See. UDL stops here. Put full UDL. How much? 36 kilonewton per meter for a length of full 5 meter. And find what is the slope and deflection at the free end. It will come this way. See, full curve. This deflection is downwards of 36 into 5 power 4 by 8 EI, and the slope here is 36 into 5 cube by 6 EI clockwise. Tell the answer. Tell the answer. Both deflection and slope. First tell me deflection. 36 into 5 power 4 by 8 EI is the deflection. Answer. Full UDL you consider. 2812.5 by EI. That much downward, see here, downward. And slope 3750 by EI. Now anybody can tell what I am doing. Now consider same cantilever. See, actually UDL is only from C to B. This is A, this is B. Point C is here. Actually UDL is from B to C. A to C, we took extra UDL. For that UDL, put upward UDL of how much? Same 36 kilonewton per meter. Clear? Introduce upward UDL. Clear now? Introduce upward UDL to balance this extra UDL here. Tell me, clear or not? Clear. Now elastic curve. Tell me. Now the beam will bend upward or downward. Tell me. Now the beam will bend upward or downward. How beam will go? Up or down? Upward. Elastic curve will come this way. So now this deflection will be equal to, again, see, now one minute. No, wrong. Sorry. Why? Now the beam will bend some other way. See here. It will have curvature up to here curvature, then remaining portion will be straight, tangent. So this slope is anti-clockwise, this also anti-clockwise. Now I need this deflection. This slope is 36 into What is the span? This is 2 meter, that is 3 meter. 36 into 2 cube by 6 EI. This is 36 into 2 power 4 by 8 EI. Tell this answer. Tell this answer. First, 36, I should not write there. I should write somewhere outside. Okay, bada. I will write here. This slope is 36 into 2 cube by 6 EI. Tell the answer. 48 slope. Slope is 48. Deflection. Deflection is how much? 36 into 2 power 4 by 8 EI. Answer. 48 by EI there. This also 48 by EI only. Deflection. 72 by EI. 72 by EI. And tell me this extra deflection due to slope. How much? You should tell. If the slope is 48 here, straight line, tell me extra deflection due to slope. This is 48 slope, distance is 3. I will not explain. Because explained thousands of times. Slope is 48, this intercept. Distance is 3. This I will not explain. If somebody wants explanation, I will tell don't come to my class. If anybody gets doubt how it came means don't come to my class. Or tell me this total upward deflection. It is 144 plus 72. Answer. 144 plus 72 is the total. 144 plus 72. 216 by EI. Therefore, final slope theta at B will be, see, 750 by EI clockwise and 48 by EI anti-clockwise. By EI I am not writing. By EI, okay. By EI. Answer. 750 clockwise and 48 anti-clockwise. Answer. 702 clockwise by EI. Final deflection at B equal to, it is originally 2812.5 by EI meter, that much downward, plus 216 by EI, that much upward. See, there will be some people who will comment, most probably, they will be laughing at me. They will tell, see this guy, see this person, he tells he knows concept mathematics so strong. See, downward here, upward here, he used plus sign. He does not know mathematics. He should have used minus sign. He is wrong. When you put vector sign, you have to always use plus sign. Clear now? He is not knowing anything. He is commenting for a false knowledge. Clear now? You should not use minus sign here. If you use minus sign, it becomes added up actually. Clear? You should write plus only here. When you give vector sign, you should not use minus. Yes. Then if he comes in front of me, he will go back weeping. Ayyo, I thought he made a mistake. Then he will tell, finally, I only made mistake. He only made mistake. 2596.5 by EI. Comment fast. Answer tallying or not tallying. That word, waste of time asking. Anyway, tallying, answer. That I cannot see the answer. That side light problem, I cannot see the answer. Tallying, light problem, I cannot see. From here, board is not visible. Okay, now, I will give one question. You have to try it. Will you try it? If you don't get the answer, I will explain next time. Will you try it? Right now you try it. Okay. Right now you try it and tell the answer. I will give 5-10 minutes time. Once upon a time, there is a cantilever beam of this way, non-prismatic. This length and this length are not Usually examination, if they give equal length, I'll give unequal length. See, once again, this is 4 meter, this is 3 meter. Okay, start. This is 3 EI, this is 2 EI. Usually they give EI and 2 EI. Deliberately I am giving 2 EI, 3 EI. Okay. There is a point load here of anything 60 kilonewton. This is A, this is B, this is C. I want slope and deflection at C and also at B. At B will be maximum values, correct? I want slope and deflection at C and B. Exam, they can ask any one of them. Clear? I want slope and deflection at C and B. I will tell you procedure. And I will give the answer and go. You should tell you got, I will explain the question briefly. See, briefly. First option, use moment area method. BM is 0 here. First use moment area method. 0 BM here, 7, 16 to 7. Oh, it is 420. It is 420 here, 0 here, joined by a straight line. Then, this full BMD you cannot use because somewhere 2 EI, somewhere 3 EI. See, this full is 420. 420. Now, what you do is, you also require this ordinate. That is 16 to 3, 180. Then divide into parts. Then this is 180 and this is from 420 subtract 180. What is the answer? From 420 subtract 180. Answer. Fast. 420 subtract 180. Fast. Don't waste time. From 420 subtract 180. 240 by EI. EI illa. ಈಗ ನೋಡಿ, now if I use this diagram, I should divide by how much? Tell me. If I moment of the BM by EI diagram, if I use this diagram, I should divide by how much? I should divide the answer for anything you use for this diagram. I should divide by how much? See, BM by EI diagram required. If you use, see, this is 4 meter, this is 3 meter. If I use this diagram, I have to divide by how much? Any calculation for this diagram. Suppose at area, half into 3 into 180. No, divide by EI is there. If you use this diagram, you have to divide by how much? 2 EI. Remember, 2 EI. Whereas, if I use this diagram or this diagram, for both the diagrams, this diagram or this diagram, you should divide by how much? Tell me. Should divide by how much? You should divide by. If you use this diagram or this diagram, divide by, not 2 EI. Fast. Divide by. Fast. Answer. If you use these two, this rectangle or triangle, divide by 3 EI. Tell me. Fully clear? Now, when you want slope at B, full area. This area by 2 EI, this area by 3 EI, this area by 3 EI. When you want moment about this point, moment of this area by 2 EI, moment of rectangle by 2 EI by 3 EI. When you want slope and deflection here, only this side you have to see. Both divided by 3 EI. Now, can you find theta C, then YC, then theta B and YB? Tell me fast. Can you find all this value? Answer in terms of EI. Can you find now? Tell me. Can you find or not? Can you find? Fast. Yes, okay. Now, find it. Now, go for trick. Consider only AC. Only AC. AC is like this. Remember, it has got 3 EI here. And remaining portion is straight. No effect. There. I consider only AC for a length of 4 meter. Okay, start. Remove, this is C. This is A, this is C. Remove that load and apply a load of 60 kN here and a couple of, tell how much? Apply a load of 60 kN and a couple of, how much? Apply a load of 60 kN and a couple of, how much? You work out correctly. Tomorrow, before next class, I will do one thing. Before the class, full board I will write and no explanation. Because by those by difficulty, I will write fair copy here, but won't explain. I will tell, take a screenshot and go to next question. Answer, that couple. 180 kilonewton meter. Okay. Now, elastic curve will come. Curvature here, straight here. This deflection and this slope and this slope and extra deflection and therefore total deflection you can find. I will tell you how to find. Next time I will write the step. I don't have. Tell the answer fast. I don't have calculator here. Tell the answer. 60 into deflection. 60 into 4 cube by 3 plus 180 into 4 square by 2. Answer. Don't give wrong answer. 60 into 4 cube by 3 plus 180 into 4 square by 2. Fast. 60 into 4 cube by 3 plus 180. Don't give wrong answer. 60 into 4 cube by 3. Don't divide by EI. 60 into 4 cube by 3. This formula 3. 180 into 4 square by 2. Answer. You are not giving. I don't have my calculator here. Instead of 27, how much? 2720. But divided by 3 EI. Answer. Divide by 3 EI. Answer. That is the what? Formula. See, formula is what? WL cube by 3 EI. WL cube by 3 into respective EI. Answer. Divide it by 3 EI. Why? Formula is what? WL cube by 3 EI. But where EI is there, you have to use 3 EI. Divide the answer by 3. ಬೇಬೆ ಕೊಡಿ ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಟೈಮ್ ಆಯ್ತು ನನಗೆ 906 ಪಾಯಿಂಟ್ ಸುಳ್ಳು ಹೇಳ್ಬಾರ್ದು 906 ಪಾಯಿಂಟ್ ವಾಟ್ 667 ಓಕೆ ಸ್ಲೋಪ್ ಟೆಲ್ ದ ಸ್ಲೋಪ್ ಬೈ ಇ ಐ ಟೆಲ್ ದ ಸ್ಲೋಪ್ 60 into 4 square by 2 plus 180 into 4 answer without EI. WL square by 2 for point load, WL ML for couple. Slope 60 into 4 square by 2 plus 180 into 4. Answer 60 into 4 square by 2 plus 180 into 4. Bega. Slope. ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಸ್ಲೋಪ್ ಕೊಡೋಕ್ಕೆ 60 into 4 square by 2 plus 180 into 4. I would have as well better got the calculator myself only. 1200. Divide by 3i. Divide by 3i. Answer. Divide it by 3. Because my formula is by EI is there. Everywhere divide by respective EI. When you put WL square by 2EI, 2 into 3EI. Answer divided by 3. It ಬೇಕಾ I go and get my calculator. 400 by EI. This also 400 by EI. And extra deflection. 400 into 3. 3 meter. This is 3 meter. ಬೇಡ ನಾನೇ ಬರೀತಿ ಬಿಡಿ 1200 by EI. Total deflection. 1200 plus 906.667. ಬೇಗ ಹೇಳಿ ಟೈಮ್ ಇಲ್ಲ 1200 plus 906.667. ನೋಡಿ ಈಗ 1200 plus 906.667. That side EI is not considered. 1200 plus 906.6 is the final deflection here. ತುಂಬ ಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ ನೀವು. You are delaying like anything. This is called testing the patience. 2106.667 by EI. ಈಗ now take a new cantilever where you apply only point load 60. Length is 3 meter. ಹೇಳಿ. For this one, slope here 60 into 3 square by 2 EI. 60 into, don't divide by that EI. 60 into 3 square by 2 EI. Answer. 60 into 3 square by 2 EI. ಎಷ್ಟೊತ್ತು ಮಾಡ್ತೀವಿ? 60 into 3 square by 2 EI. Don't use that given 2 EI. That 2 is formula 2. ಆಮೇಲೆ ಯೂಸ್ ಮಾಡಿ ಸರ್ ಮುಂಚೆ ಯೂಸ್ ಮಾಡಿ ಅಂತ ಒಪ್ಕೊಳ್ಳೋಲ್ಲ ನಾನು. 60 into 3 square by 2 EI. ಎಷ್ಟೊತ್ತು ಬೇಕು? 270. Then divide by 2 EI. Why? This cantilever has got 2 EI here. Divide by 2. That EI 2. ಬೇಗ ಬೇಗ. Divide by 2. Tomorrow, next class, I will write on the board. ಪುನಃ 270 ಅಂತೀರಿ. Divide by 2. ಡಿವೈಡ್ ಬೈ 2 ಮಾಡಿ. 2 EI ಇದೆ ಅಲ್ಲ ಅಲ್ಲಿ. ಡಿವೈಡ್ ಬೈ 2. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಏನು ಮಾಡಿ ನಾನು 5 ದಿವಸ ರೆಸ್ಟ್ ತಗೊಳ್ಳೋ, ಬಿಕಾಸ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಈಸ್ ದೇರ್. ಐ ಥಾಟ್ ಐ ವಿಲ್ ಟೇಕ್ ಲಿಟಲ್ ರೆಸ್ಟ್. ಯು ಆರ್ ನಾಟ್ ಅಲೋವಿಂಗ್ ಮೀ ಟು ಟೇಕ್ ದ ರೆಸ್ಟ್. ಡಿಫ್ಲೆಕ್ಷನ್ 60 into 3 cube by 3. 60 into 3 cube by 3. ಅದು ಬೇಗ ಹೇಳಿ. 60 into 3 cube by 3. That is the formula. Next time I will write. Today time is not there. That's why doing fast. Actually, how much I explain, those who are sharp will understand. So next time, full board, I will write solution. But before the class, ಇನ್ನೂ ಅಲ್ಲೇ ಇದ್ದೀರಿ 135 ಅಲ್ಲಿ. 60 into 3 cube by 3. 540. Divide by 2 EI. ಬೇಡ, ಇದು 270 by EI. Correct? Divide by 2 EI. ಇನ್ನೂ ಅಲ್ಲೇ ಇದ್ದೀರಿ. ಇನ್ನೂ 2 ಈಗ ಆನ್ಸರ್. ಸ್ಲೋಪ್ 400 plus 135. ಎಷ್ಟು? 400 plus 135 ಬೇಡ, 535 by EI. ಡಿಫ್ಲೆಕ್ಷನ್ ಲಾಸ್ಟ್ ಹೇಳಿ. 270 plus 2106.667. 270 plus 2106.667. Today's last answer. 270 plus 2106.667. 270 plus 2106.667. ಎಷ್ಟು ಟೈಮ್ ವೇಸ್ಟ್ ಆಗ್ತಾ ಇದೆ ಬಾ. I thought I would take extra 10 minutes rest today. You spoiled the complete rest now. Now it is actually approaching 9, already 9. See, I thought 2376.667 by EI. Okay. See, this is the answer for moment area method and also by our shortcut. Okay. Can you try yourself now? Tell me. Can you try? Anyway, see, usually I never do this way in the class. This is not my usual class because time is not there. What I did is at least some homework type for you. Those who are sincere, they will get the answer. Others, next time, full board I will write. Clear now? At least those who are serious and dedicated can try something. Clear or not? Otherwise, this way class I never take. Okay, thank you.